Hey, what's up you guys? It's Courtney here. We're going to be starting with problem 1 on PQ for fall 2015. So it says, what is the IUPAC name for the following compound? And it's given us a compound over there in the box, and it's given us a multiple choice answer. So the first thing we're going to want to go over is our naming rules, which we're going to include a link in the video. So if you want to click that on the screen, it'll take you over to our first naming rules video. And Angel's got an excellent explanation for it. So if you're not comfortable with that, by all means go over and review it first, and then just click back here. But if you do feel comfortable with naming rules, we're just going to jump right in. So the first thing that we're going to do is always find the longest carbon chain that includes a double bond when we're naming alkenes. And in naming alkanes, we have to remember that alkanes cannot rotate around the double bond. Thus, cis and trans, or E and Z, will have to be assigned to the molecule, which we will go over in just a moment. So, finding the longest carbon chain, we've got 1, 2. Finding the longest carbon chain, we've got 1, 2, 3, 4, 5, 6, 7. Okay, so we know that this is going to be a heptene, because it does have a double bond. It is an alkene. So right away we can cross off D. All right, the next thing we want to go over is we have to make sure that the double bond, as well as our groups, our methyl group and our bromine, have the lowest possible numbering. So if we start on this side, going from 1 to 7, we will end up with B, which is 4 bromo, 5 methyl, 4 heptene. But if we go from the opposite side, going from 1 to 7, from right to left, we'll see that we get 4 bromo, 3 methyl, 3 heptene, which is what we're going to use because that is the lowest numbering, so we can cross off B also. So the next thing that we have to go over is assigning the E and Z groups for this problem. We could also be assigning cis and trans when we name alkenes, so it's important to note the difference. E and Z is used when we have 2 different functional groups on each carbon on the double bond. So that can look like, if I give you guys an example, that can look like if we have it, kind of similar to how we have it in the problem. If we have a methyl, methyl, and then hydrogen and like a bromine over here. So as long as we have 2 different functional groups on each side, we can assign E and Z. And we can also assign cis and trans to this because we have 2 different groups attached to each carbon that is attached to the double bond. And in this case, it would be a trans molecule because we've got the methyl and methyl on opposite sides. So if we had a double bond on our first and second carbon, we will not be assigning cis and trans or E and Z because we've got 2 H's coming off. That is not 2 different functional groups, so we cannot assign cis and trans or E and Z to this molecule. So let me just get rid of all that for you. All right, so when it comes to assigning priorities, I just like to draw the molecule again. So we've got our propyl group up here, bromine right here, double bond across to our ethyl group, and our methyl group. So when we assign priorities, I like to just draw a line through the middle because we're only considering the right and left sides as separate entities. So we've got our ethyl group on the right side and our methyl group on the right side. So when we're comparing the two based on molecular weight, because that's how we assign the priorities, it's based on molecular weight of the substituents. So we've got ethyl, which is going to be 1, because the molecular weight is greater than that of methyl, which is 2. We've also got, on the left side, we have bromine and our propyl group. And bromine is obviously going to have the higher molecular weight, It's further down the periodic table, so it's going to have a much higher molecular weight than that of purple. Purple is going to be 2. So let me just shrink this down. And then we can just draw it again, just to clean things up. So we've got 1 and 2, 1 and 2. And since we are only looking at our 2 highest priority groups, which are the 2 number 1s, we're going to just circle those. And because those are diagonal from each other, this is going to be E. If the 2 groups were, let's say, that the bromine and the propyl switched places, then we would have 1, 2, 1, 2. They would be on the same side, or Z same side, so we would consider this to be Z. But because it is not Z, let me just get rid of that there. Because it is not Z, we can cross out C as well. So our answer is going to be A.